Okay, this is part of the probability workshop number 2, and we're going to just start here. We've got a question here, and it says that the probability for two events, A and B, the probability of A is 0.2, 20%. Probability of B is 0.63, 63%. But the probability of A and B is 0.126. Okay, now the question is, are A and B mutually exclusive? Well, I might go back to this very introductory thing, and we're all going to get this little piece of paper here. If you have that something is mutually exclusive, then the probability of A and B has to be 0. It means the two probabilities don't touch. It means there's nothing between them. They're mutually exclusive. So the first question, are they mutually exclusive? Well, right away, they're not. Why aren't they? Because the probability of A and B is not 0. So there you go. But to do the next question, they're definitely not mutually exclusive because this isn't 0. That's a rule. Okay, so now let's look at this. What's the probability of A or B? Well, what you have to do is they told you the probability of A is 0.2%. You actually put it outside. Make a Venn diagram like here. And the probability of B is 63%, 0.63. And you put that outside there like that. Now, they told us the probability of A and B, where they cross over, it's 0.126. But all of A adds up to 0.2. So you just go 0.2 minus the 0.126, and that's how I got this 0.074. And that's your answer for only A, the probability of only A, the one that should go right there in the Venn diagram. Now, out here, we know that B is 0.63. If we subtract the intersection here, A and B, we're going to get the part that's only B. And that's 0.63 minus this is 0.505. Now we have enough information to answer all the questions like, what's the probability of A or B? Well, I'm looking at it. It's these three things added up. That's one way to get the answer, 0.704. Or you can always use the formula. The probability of A or B is always the probability of A plus the probability of B minus the probability of A and B in the middle. If we do that, 0.23 plus 0.63, and we minus what's in the middle, 0.126, we get exactly the same answer, 0.704. And the last question is, are these events independent? Well, on this little sheet I gave you back here, if they use the word independent, this is the test for it. If P of A and B are independent, then if you multiply their probabilities, their individual, the probability of A and the probability of B, if you multiply them together, you'll get the probability of A and B in the middle. Well, just test it. Go 0.2 times 0.63. Hey, that is the probability of A and B. That's what they told us in the beginning. So we say, yes, they are independent because they multiply to equal the probability of A and B. Well, that's question 1, and it turns out that question 2, I just kind of repeated. It's actually the same question. It was used in a different exam, but the same. So question 1 and 2 on your sheet, hey, that's the answer for question 2 as well. So we'll start the next video with question 3. We'll start the next video with question 3.